Hi. So, you know when you get to a test and you see that there's a lot of room to write and you're like, oh boy, I'm going to get to do so much work on this test? Or maybe it's a feeling of dread a little bit, but I'm going to guess it's like mainly excitement. Look at the pages we're doing today. Do you see how there's only one problem on this page? And then one on this page? And one on this page? That means you get an entire page to write. Yes, that means we might have to write a little bit, but you get the whole page to do it. So that's exciting. And we're only doing 3 problems. Okay, so let's begin. I'm so sorry. It's like the anticipation is almost too much. I know. Okay, so in this one, we've got, I want to know, determine the intervals for which f of x is increasing, decreasing, and find all coordinates, meaning an x and a y value of relative extrema, and unless otherwise noted, perform the analysis on all values, negative infinity to positive infinity. And this part's really important, provide justification. So we're going to do this. We're going to say, okay, when is this function increasing or decreasing? A function is increasing when its derivative, the slope of the tangent, so f prime of x, is positive. Or decreasing, the function is decreasing when f prime of x is less than 0. Or you can say has a relative max or min when f prime of x is equal to 0, and you would have to say changing it from positive to negative or negative to positive. In all of these cases, what you actually need to do first, though, is take the derivative, and then you have to set it equal to 0 in order to find out any of the rest of these to see where those changes possibly are occurring in the graph. So let's do that. So I'm going to take the derivative here. Take a moment, you do it. Use the power rule. You don't have to do the long limit as h approaches 0 way. Okay, did you get 3x squared minus 6? And then the next thing I want you to do is set it equal to 0. So I'm going to say 3x squared minus 6. Add 6 on both sides, I get 6 is equal to 3x squared. Divide both sides by 3. And then I'm going to square root both sides. Remember, since you introduced the square root, you would have to say x is equal to plus or minus the square root of 2. Okay, this is good. And now I'm going to be thinking, well, you know what? I need to figure out all those intervals knowing from negative infinity to positive infinity. I'm working with a polynomial, so I'm thinking the entire domain is negative infinity to positive infinity. And I want to figure out where is there something happening where f prime is equal to f prime of x is equal to 0. That's a positive and negative square root of 2. So I'm going to make a table, and I'm going to say my x values are from negative infinity to negative square root of 2. There is a slightly shorter way of doing this, but I have learned that it's better to write this all out and know how to do this really well right now. So go with me. So a negative square root of 2, f prime of x is 0. And then I'm going to keep going and say, okay, well, the next interval where something happens would be, I'm going to keep going from negative square root of 2 to square root of 2. Because I know at square root of 2, I get 0. So this is an interval. This isn't a point. Negative infinity, negative square root of 2. This is an interval, not a point. Then square root of 2 to infinity. And so what I really want to know is in these other places, I know that the derivative or the slope is 0 here and here. But I want to know what's going on in the other places. Is this function positive or negative? Since it can't be 0, it has to be one or the other. So I'm going to pick a number. You can pick your favorite number from negative infinity to negative square root of 2. What's your favorite number? Wait, did you say negative 100 also? We have so much in common. Okay, so negative 100. If I go back up to f prime of x, so f prime of negative 100, I'm just writing there somewhere, I would have 3 times negative 100 squared minus 6. I don't actually have to calculate this. I just know this is going to be a negative times a negative, which is going to be positive times 3 minus 6. This whole answer will still be positive. Which means I know that f of x, if its slope, or if f prime of x is positive, that means f of x is increasing. And then I do the same thing here. Negative square root of 2 to square root of 2. Pick your favorite number in that interval. Wait, did you pick 0 also? that's what I picked. Maybe you pick something else, it's okay. It will still work out. 0 is just the easiest number that I can think of. If I had 3 times 0 squared, so f prime of 0, you don't have to write this part out. I'm just doing it so I can show you. Often I won't. Would be 0 times 3. You get 0 minus 6, negative. Don't just automatically assume if you got positive here, it's negative here. It's not always that way. But that means f of x is decreasing. And then from square root of 2 to infinity, negative 5,007, or I'm sorry, positive 5,007. I was doing this one. If I take this number and I say f prime of 3 times positive huge number squared times 3, positive huge number, minus 6, still positive. So that means f of x is increasing. So we do all this work and you're like, I didn't use up my whole page yet. Don't worry, there's more to do. Down at the bottom it says, unless otherwise noted, perform the analysis and provide justification. I need to actually write out the stuff in the table. This is not enough. And the reason why it's not enough is because College Board says it's not enough to just make a table. This is called a sign chart. Ours is a little bit more involved in any sign chart that I've seen on those exams, but it's still not enough. So I'm going to say, answer all the questions. I want to determine when f of x is increasing or decreasing. So I'm going to say f of x is increasing on the intervals. And I'm just looking right up above and I'm going to say negative infinity to negative square root of 2 and square root of 2 to infinity. And my justification is as f prime of x is greater than 0. The next one I'm going to do the same thing. So you try to write it down that f of x is decreasing. Fill in the rest of the sentence. On the interval, negative square root of 2 to 2, square root of 2, as f prime of x is greater than 0. I also saw something that said, what should go on here? And it says, determine, find all coordinates of the relative extrema. So, relative extrema, if I'm thinking about increasing to decreasing, that means right here, there's going to be a relative maximum. Decreasing to increasing, a relative minimum. So I'm going to say f of x has a relative minimum, or a relative max. I'll go with that one first. At, sometimes you can say x is equal to negative square root of 2, and this one you can't because it asks for the coordinates. So I'm going to say negative square root of 2, and this is where it's going to be really crazy because you actually don't have to do too much in this. You go up here and you say, what is f of square root or negative square root of 2? You can leave your y value as something crazy like this. You can say that this one, do I even have this in here? No. My y value could be negative square root of 2 cubed minus 6 times square root of negative 2, or negative square root of 2, sorry, plus 1. Ta-da! This is a gross point, this is an x value, this is a y value, and I'm going to move on with life. If you wanted to put this there, now it's in parentheses. Or you can find the decimal, just make sure you use 3 places after the decimal to that accuracy. And I'm going to say as, this is my justification, as f prime of x changes from positive to negative. Okay, and then another one, last thing. Oh man, I'm even going off the page here. I should have written smaller. Has a relative min at, I'm going to go up here, x equals square root of 2. Oh, I shouldn't even say that. Hold on, coordinates. Square root of 2. And this would be square root of 2 to the 3rd power. All my face is in the way. Minus 6 times square root of 2 plus 1. Gross. Most of the time you can just say as x equals square root of 2. And then you want to say as f prime changes from negative to positive. You could have also said, instead of f prime changes from negative to positive, you could have said f of x changes from decreasing to increasing, because you already used that information and told me when I was increasing and decreasing. So it's just using the work done here. But to be on the safe side, I would just go negative to positive. Whew, that was one problem. Do you need to stretch out your fingers at all? Just be like, for exercises, do some finger exercises. No? Okay, let's keep going on then. You're like, one more problem. You get two more, so don't even chant that because you'll sell yourself short. You get two. On the next page, this one looks pretty similar to the last one. So, what was the first thing you did if you're trying to find the intervals of increasing, decreasing? The first step is to find the derivative. I'll do that now too. Okay, I did that. Then what should I do? I feel like I'm on a terrible kids show because there's not even like, I don't even know. You know when they ask somebody like Dora the Explorer and she talks to the camera right now? That's what I'm doing to you. Except I'm asking you what you should do next. So it's more like a more interesting Dora the Explorer. Okay, so I'm setting this equal to 0 if that's what you said. You're right. And then this one, depending on how you solve it, you could forget about a 0 in here, and I don't want you to do that. So if you see something that has an x and another x term over here, I want you to try to factor out, but don't just divide immediately. Because right now I can set each component, 15x squared, equal to 0. And so I know I need an x equals 0. And then I can set x squared minus 1 equal to 0. That means x squared is equal to 1, or you could have done this and set x minus 1 times x plus 1. Either way, you would get x equals negative 1 and x equals positive 1. Same thing here, because you do plus or minus the square root. So I've got these values. Okay, what's the next thing to do? Find the intervals. So, or at least write the intervals. This will be x, f prime of x. Make sure that you label. And then we're going to have an f of x at the very bottom. So I'm going to go from negative infinity to my first issue, the first place where my derivative is equal to 0. So negative infinity to negative 1, because at negative 1 I know the derivative is 0. And then I'm going to go from negative 1 to 0, because that's the next interval, because after that 0, f prime of 0 is 0. Then I'm going to go 0 to 1, because I know at 1, f prime of x is equal to 0. And then 1 to infinity. Were you hoping we'd have a couple more intervals? It's okay. Okay, so now I've got this chart. What should I do next? Did you say pick your favorite number? It really does sound like, I don't know, Dora the Explorer when they're like, did you say go across the bridge? Say go across the bridge. But I'm not actually meaning to talk to you like that. Just saying I want you to just pick a number. Okay, so negative infinity to negative 1. So I'm going to go back up to f prime of x. And I'm actually going to rewrite this one so that it's easier to substitute into. I'm going to rewrite this one as 15x squared times x squared minus 1. Just so when I substitute a value like negative, I don't know, negative 100, substitute in here, I get a positive times a positive. This is still going to be positive times a positive, and I get positive. Picking a number from negative 1 to 0, I'm going to pick negative a half. So if you think about this, negative a half, 15 times negative 1/2 squared is still going to be positive because I have negative times a negative. It doesn't matter what this number actually is. But then when you do negative 1/2 squared in the inside, so negative 1/2 squared, make sure you put in parentheses, I get 0.25 minus 1. Oh no, that's negative. From 0 to 1, if I put in 1/2, same thing's actually going to happen. This one is going to end up being positive. This, for the same reason, because negative 1/2 squared and positive 1/2 squared are the same thing, minus 1 will be negative. 1 to infinity, let's say I put in 5,000. 5,000 squared is still positive, times 15, still positive over here. So right now, you know all of the rest of these answers. You can say, okay, I know that f prime of x, the slope is positive. That means f of x is increasing. I was going to write the rest. I'll write it. When the slope is negative, that means f prime of x is decreasing. And then at 0, if I'm going from increasing to decreasing or decreasing and decreasing, we'll talk about that, decreasing to increasing. Here, increasing to decreasing, where the slope is positive to negative, this is a relative max. Over here, I've got a relative min. Both of these values, I could have said, are horizontal tangents. And the reason is because f prime of x is equal to 0. In this particular one in the middle, this is the only thing I could say, because this function is going from decreasing to decreasing. So it's going to be decreasing and then level off for a little bit. I really exaggerated this, but level off where this slope somewhere is going to be 0, and then keep decreasing again. Okay, so if I'm writing all of these, because we're not quite done, I know you were thinking, I hope there's one more thing that I need to do. You need to write all of these answers and say, f of x is increasing on the intervals. And it's negative infinity to negative 1 and 1 to infinity. And the reason is as f prime of x is greater than 0. F of x is decreasing. You try it. On the intervals. And I'm actually going to stop where it says stop. So negative 1 to 0, 0 to 1. And the reason is as f prime of x is less than 0. F of x has a relative max. A relative max. Do you have a relative max? Do you have like an Uncle Max or something? Okay, has a relative max at, I was going to say at x equals negative 1, but I'm going to say this time f of negative 1. And the function value at negative 1, because this is still a coordinate, 3 times negative 1 to the 5th is still going to be negative 1. Minus 5, it's still going to be negative 1 because it's raised to the 3rd power. And I get 2. So you could say at the point negative 1, 2, and write it as like parentheses, and then, you know, parentheses, negative 1, close parenthesis after the 2. And I'm going to say as f prime of x changes from positive to negative. Remember, you could have said because f of x changes from increasing to decreasing, because we already did this part. And then I'm going to say one more, f of x has a relative min at f of 1 equals, and if I do the same thing as before and I come up here and I put in 1, 1 to the 5th power is 1, so I get 3 minus 5, I get negative 2. I want to make sure I didn't mess something up. No, I think I'm good. This would be the same thing as before, except I'm putting in. Yeah, we got negative 2. I don't know why that was so hard for me right now. I'm very tired. As f prime of x changes from negative to positive, or you could have said f prime of x changes from decreasing to increasing. Okay, were you hoping? One more problem, please. Please, can we do one more? And don't just make it a regular problem. Make it involve trig in some way. Well, you got it. Okay, so the first thing that you do on any of these problems when you're trying to figure out intervals of increasing, decreasing, max, or mins, what's the very first thing? Yeah, take the derivative. The derivative of theta is not 0. This is not a constant. This would be like the derivative of x. And if you think about like y equals x plus 2. Just that line. What's the slope of that line? Be like, oh, it's 1 because there's a 1 here. Same idea, there's a 1 here. So I'm going to say 1 plus the derivative of sine is cosine. You bring along that 2 for the ride. What's the next thing that we do? Yeah, set the derivative equal to 0. And then we solve. Because now we want to find the interval. So we're thinking, okay, well, what's next? I want to say negative 1 is equal to 2 cosine of theta. divide. Negative 1/2 is equal to cosine of theta. Okay, here's where you have to think, and you have to go through a bunch of triangles in your head or something, and you have to think, where is cosine of theta equal to negative 1/2? So if you need to write some triangles of some sort, to do it that way, if you need to do some trig values. But I'm going to say, in my head, this is pi over 3, this is pi over 6. This one would be 1, and then I would get this as, I'm trying to think. This would be 1, this would be, I went on a brain freeze for a second. If we did cosine would be adjacent over hypotenuse. I'm saying this weird for some reason. Why am I doing this? Pause. Oh, that was right. Okay, so you'd be making this triangle over here. So we've got pi over 6. This is the smallest angle. So you've got 1 across from that. You would have square root of 3 over here and 2 over here. And so I'm trying to think of, okay, what is going to give me 1/2? Don't even worry about the negative right now, but just 1/2. And I would think, okay, it's this angle, adjacent over hypotenuse, cosine of pi over 3 equals 1/2. So I'm like, okay, good. This is my good like base angle. But then I have to think I've got negative. Awesome students take calculus, and this would be 0, and this would be pi the whole way over to 2 pi. And this just says on the interval from 0 to 2 pi, so I'm not looking like to keep going on forever and ever past this. But if I say negative 1/2, I would have to be in a quadrant where cosine is negative. So here or here. So I'm thinking, okay, I've got pi over 3. If I go, pi over 3 is in the first quadrant, so that's not going to work. What about 2 pi over 3? 2/3 of the way to pi, that'd be in this quadrant. That would work. And then I think, well, what's down here? 3 pi over 3 is just pi. That wouldn't work. Ooh, 4 pi over 3 would work, because that would be in this quadrant, except if I'm using a reference angle. Cosine, that's not going to work. So I'm not going to say 5 pi over 3 because cosine would be positive. Okay, so now my interval's a little weird, but that's okay. So next thing, you're making a table. And instead of starting at negative infinity, I'm just going to go to 0. So 0 to the first stopping point is 2 pi over 3. Because I know at 2 pi over 3, f prime of theta is 0. 2 pi over 3 to 4 pi over 3, because I know at 4 pi over 3, f prime of theta is 0. And then at, I would go a little bit more. 4 pi over 3 the whole way to 2 pi. And so this one is probably trickier than the other ones, besides the fact that we're dealing with trig, because then you have to find a value between 0 and 2 pi over 3. So take a minute, do this, and you want to say, okay, if I have a value of pi over 3, and I went back up to here, that's where I'm substituting in, back into my derivative. I want to know whether my slope of my tangent is positive or negative. If you say 1 plus 2 cosine of pi over 3, and you want to know if this is positive or negative. Well, cosine of pi over 3, we know from up here, was just positive 1/2. 1 plus 2 times 1/2 is going to be 1 plus 1. We get something positive, so we're good. And then 2 pi over 3 to 4 pi over 3, I think of 3 pi over 3. So I'm thinking 3 pi over 3 is just pi. So I'm thinking of the cosine curve at pi. So 1 plus, sorry, my head's in the way, 2 cosine of pi. Cosine of pi is just going to be -1. 1 plus 2 times -1 is going to be negative. And then if I say 4 pi over 3 to 2 pi over 4 pi over 3 to 2 pi, I'm thinking about 5 pi over 3. 5 pi over 3 was going to be the same thing. So if I change this one and just say 5 pi over 3, it's going to be the same deal as here, except it's in this quadrant, which would make this one still a positive 1/2. So I get 1 plus 2 times 1/2, which is still going to be positive, which means f of theta is going to be increasing, decreasing, increasing, increasing, decreasing. There's a relative max right here and relative min right here because it's decreasing and increasing. If you want to see me watch or write the rest of this, this is going to do some magic and just skip to that so this doesn't get crazy long. But thanks so much. Yeah, I'm not saying thanks yet. I'm going to do this first and just edit this part out. Okay, so I'm going to say when f prime of x is positive, or you can say it's greater than 0, f of x is increasing. I changed up the order of this, that's fine. When f prime of x is positive, f of x is increasing, and this occurs on the interval 0 to 2 pi over 3. And 4 pi over 3 to 2 pi. When f prime of x is less than 0, so or is negative, f of x is decreasing. This occurs on the intervals 2 pi over 3 to 4 pi over 3. I don't know why I'm saying this still because I'm going to cut this part out. And I'm going to say at f 2 pi over 3 equals 2 pi over 3 plus square root of 3 is a relative max. And poof. Here are all my answers for this. Thanks so much for being great. I appreciate you. Thank you for doing work. If you don't understand any of this, please, please, please let me know. I think you're awesome. Okay, bye.